Hi, guys. Okay, so let's look at the problems on Avogadro's law and Dalton's law in this video. So we're looking at problem number 41, 43, and 63. So let's look at this. 41. 41 is saying that a sample of 25 grams of neon is added to 1.50 moles of neon in a container. And for 1.50 moles of neon, the volume is 8 liters. So find the volume when 25 grams of neon is added to 1.50 moles. So first thing is, it's very important you write down the formula. So the formula is V1 over N1 is equal to V2 over N2. So here we need to find the value of V2. And when N2 is, for a higher number of moles. So V1 over N1 is times N2 is equal to V2. So that's the double, the rearrangement after you add the rearrangement. Now, we are going to convert 25 grams of neon to moles of neon. And these moles of neon is the value of N2. Now, not actually the moles of N2. N2 will be actually after adding. So 25 grams neon times 1 mole of neon over 20 grams of neon. Now that number you get from the periodic table. So this comes out to be 1.25 moles. Now these moles are added, and they are added to the 1.50 moles. So that would be the value of N2. So 1.50 moles plus 1.25 moles. And this gives you 5, 7, and 2.7975 moles. So that's the value of N2. So rest is you just plug in V1 over N1 times N2 is equal to V2. So V1 is 8.00 liters over N1 is 1.50 moles times 2.75 moles. Okay, and that is the value of V2. So let's do the math. Okay, so 8 times 2.75, divide that by 1.50, and you're going to get the moles of the value of the volume, the second volume after the addition, and that is 14.66. Okay, so that's one piece. Next is, let's look at problem 43. At STP, now we already know that at STP, whenever the STP comes, that means the pressure is 1 atm, temperature is 273 Kelvin or 0 degree Kelvin, 0 degrees Celsius. Sorry, and the volume is 22.4 and the number of moles is 1. So that's the standard. Now, since this is the Avogadro's problem where we are looking at the relationship of volume and the number of moles, so at STP, our V1 is 22.4 liters and the N1 is 1 mole. Okay, so that's the 1 mole. So that's standard. So this we will use. Next, we need to find how many moles of oxygen are present in 44.8 liters of oxygen. So write down the formula. And here we are trying to find the number of moles, N2 value. So rearrangement. And here you will see N2 is equal to V2 times N1 over V1. Okay, so V1, N1, and V2 are all known, and then the N2 is unknown. So let's just plug in the numbers here. So N2 is equal to V2, 44.8 liters times N1 is 1 mole over the volume 22.4 liters. So 44.8, divide that by 22.4, and you're going to get the value of 2. So these are the number of moles of oxygen in 44.8 liters of volume of oxygen. Okay, so that's one piece. Now we are going to look at the problem 63. 63. In this, we are given a mixture of helium, nitrogen, and oxygen. The total pressure is given. We are given the pressure, the partial pressures of oxygen and helium, but we need to find the partial pressure of nitrogen. So write down the formula. P total, this is the Dalton's law. P total is equal to P of helium plus, that's the partial pressure of nitrogen, plus partial pressure of oxygen. So write down what is given to you and what you need to find. So we need to find PN2, but we are given the helium is 75 torr. And the good part is just, leave the units are the same. If the units are not the same, then you need to convert. So 75 torr is 1. And just move this here a little bit. Okay, next is the plus PO2. PO2 is 425 torr. 425 torr. And this is equal to the total. The total is 925 torr. Always write down the units. 925 torr. Okay, so next is rearrangement. So P total minus the partial pressure of helium minus the partial pressure of oxygen. And that is going to give you the partial pressure of nitrogen. So 925 torr, 925 torr minus 75 torr and minus 425 torr. Okay, so let's see what do we get here. So 425 plus 75, that is equal to 500, but negative. So 500 torr and 925 torr minus 500. And that gives you 425 torr. And that is the partial pressure of nitrogen. Okay, PN2. And that is PN2 is this. Okay, so that's how you calculate that. So the answers, you can always double check and check from the back. The answers are correct. Okay, so this is correct. You can self-check your answers. This is correct and this is correct. All right, so in the next video, we are going to look at the other problems from the gas law. All right, thank you.